Hello, my name is Shazia Sheikh and I'm a Network Solutions Engineer at Alcatel-Lucent Enterprise. Today, I'd like to show you how we can use the Nornir automation framework with OmniSwitches.
Let's dive right in. Here is the agenda for today. I will start with an overview of Nornir. Next, I will compare it and contrast it with another commonly used automation framework, Ansible. After that, it's time for a demo. I will explain the scenarios and show you Nornir in action. Finally, I will close with some key takeaways. Let's get started. Let me walk you through what makes Nornir stand out as a network automation tool. Nornir is an open-source Python automation framework designed specifically for network engineers. It allows you to leverage the flexibility and power of Python to automate complex network tasks. It's inventory-driven, plugin-based, and fully extensible. All devices and credentials are managed through simple inventory files. Nornir is built to support multi-vendor environments. We can automate across devices from different manufacturers all in a single workflow, making it ideal for mixed network environments. A wide range of plugins are supported, such as NAPALM, NetMiko, and Scraply. These plugins handle the connection and the management of the devices, allowing you to focus on the high-level automation logic. In summary, Nornir gives network engineers a powerful, extensible way to automate tasks across diverse network hardware, using the full capabilities of Python and a growing ecosystem of plugins. From a more mythology perspective, Nornir is named after the Norns from the Norse mythology, the beings who weave the threads of fate. Just as the Norn manages and connects every destiny, Nornir orchestrates and manages tasks across a network of devices. In this presentation, we will focus on Nornir with the use of Napalm. Napalm has already been covered in another video that you can find on our community website, spacewalkers.com. Nornir uses Python for task logic, giving you full programming flexibility, whereas Ansible relies on YAML playbooks, which are more structured but less customizable. In terms of speed, these graphs show that Nornir is significantly less time-consuming, especially as the number of hosts increases. You can see that with a few or even thousands of hosts, Nornir completes tasks much faster than Ansible, making it ideal for larger-scale automation where performance is critical. Here, we have a head-to-head comparison between Nornir and Ansible for network automation. Let's start with the approach. Ansible uses a declarative style with YAML playbooks, letting you describe your desired state, whereas Nornir, on the other hand, uses an imperative style where you write logic directly in Python script. Ansible is more friendly for beginners or non-coders, whereas Nornir requires Python knowledge, so the barrier to entry is higher if you're not already comfortable with programming. Ansible benefits from larger enterprise backing and many resources. Nornir's community is smaller, but it's rapidly growing. In summary, choose Ansible if you want something easy, well-supported, and standardized. But if you need more flexibility, speed, and if you're comfortable with Python, then go with Nornir. In this part, we will see how we can automate real-world ALE switch configuration. All of the following steps will be done using Nornir in Python script, the NAPALM-AOS driver, and templates file associated to the relevant task. We will configure 3 switches at the same time in this demo. First, we will automate the creation and configuration of VLANs on the devices and creating the associated level 3 interface to the VLANs. Then, we will create IP interfaces between our switches. Finally, we will enable SPB-ISIS on our network topology to ensure a more robust Level 2 connectivity. Nornir uses a set of YAML files to define our inventory and configuration. First, we have the config.yaml file, which is the main configuration for Nornir itself. Then, we have the host.yaml file, which is the device inventory. Finally, we have the default.yaml file, which contains all the default settings such as the login, the passwords, and it can also contain configuration which is applied on all the inventory. These files provide the necessary information for Nornir to understand what devices to manage and how to access them. Nornir uses Python scripts to define automation tasks. This script imports Nornir and initializes it using the config.yaml file. Then we have the Nornir task, which in this case renders device-specific configuration based on a template file, and uses Napalm to push the rendered configuration to each device. The first scenario is the creation and configuration of VLANs. This template contains all the device-specific configuration, such as the VLAN ID or the VLAN name, that are both declared in the host.yaml file, as you can see here. Let's now deploy our VLANs. If you want to see the changes without applying them on the devices, we can do a dry run with this setting. For this demo, I will set this setting to false and simply execute the Python script. As we only have 3 switches for this demo, it should only take a few seconds. This script shows the output of the configuration it is pushing on the switches. Here on switch 3, for example, we can see that it is creating the VLAN 130 with the name PC, and it is adding the port 1110 as an untagged member of this VLAN. And finally, it is creating an IP interface for this VLAN. Let's now go check on the switch. As you can see, we now have our VLAN 130 created on the switch. We can also find our IP interface. Let's try pinging our virtual PC. Great, it works. We can now move on to the second demo and deploy IP interface on the inter-switch links. Let's modify the Python script to use the correct template for this task. If we have a look at this template file, we can see that for each physical link, an IP interface is created. Again, all the interfaces are declared in the host.yaml file, as you can see here. Let's now run the script. Let's check on the switch now. All the IP interfaces declared in the host.yaml file have been created. Let's try to ping another switch. It works. Finally, the last scenario is SPB-ISIS deployment. This template simply contains the backbone VLANs and the ports on which SPB are enabled. Again, we just have to change the template file which is going to be applied and run the script. Let's go check on a switch if the SPB topology is correct. Great, we can see all our 3 switches. As you can see, all of these changes have been pushed to the device in just a few seconds. Nornir enables unified network automation using Python, so you can manage all your devices with a single, powerful language. It is ideal for building custom workflows, giving you the flexibility to tailor automation to your specific network needs. Also, Nornir is flexible and extensible, meaning you can easily adapt it and integrate new plugins as your environment grows or changes.
I hope you have enjoyed this brief introduction to Nornir and the demonstration. Nornir stands out because of its speed, which is key in a large network. It's based on Python, and this makes it possible to create flexible and customizable workflows. It can also be combined with the NAPALM driver for vendor-agnostic automation scripts. However, it does require more programming skills than Ansible. If you want to play with it, you can find the sample codes that I used in the demo at Spacewalker's Developer Center. Thank you for watching, and see you next time.